Okay? But before we do that, I need to tell you about something. I need to talk to you about our essay that we are going to write. I think I probably told you that I'm an English major too, and so writing is near and dear to my heart. So twice a year, we do an essay. Now, it's not anything huge, but it is a required assignment, 20 points. It will be graded like an English teacher grades. So in other words, I don't want fragments, I don't want, commas out of place. We're going to write this correctly. The essay is 1 page minimum, 1 full page. So if you've got 2 or 3 extra lines of emptiness at the bottom, you're going to get docked. It's 1 full page minimum. Do not leave a margin at the top of the page this big. You know MLA format, you know how to do it right. Here's what you're going to write about. What is, and I'll tell you when this is due, it's due right before Thanksgiving. What is one thing about you that you are thankful for? Don't tell me, I'm thankful for my parents. You should be thankful for your parents. Don't say, I'm thankful for the opportunity to take Precal. You should be thankful for that. What I want you to say is, I am thankful that I was given, or that I have developed, or that my parents have instilled in me the gift of loyalty to my friends. I'm a loyal friend. I am a responsible, conscientious student. A gift that you possess. And then I want you to tell me some examples of that. Why do you feel that way? Why do you feel you are a loyal friend? What have you done that has made you a loyal friend? What have you done that demonstrates you're a responsible student? What have you done that demonstrates you're a good big sister? Whatever it is, one talent or gift that you have that you can write to me about so that I know that one special piece about you, okay? So 1 page, typed MLA format, about a gift that you possess, one gift that you possess. Don't tell me you're thankful to be part of your family. Yes, you are. I want to know something you're thankful for about you personally. Okay? Got it? And it is due, I was going to check that date this morning, the Friday before Thanksgiving. So let's check that date. The Friday before Thanksgiving will be the 20th. November 20th. Okay? Now, we have talked about this. Everybody's clear? Any questions? Due November 20th? Anybody can turn it in early. This is an essay that can be turned in tomorrow if you want to get it done. It's due, now the one we do in the spring, you will not be able to turn in that early. But the one, this one, you can. You can turn it in whenever you get it done. But it's due the 20th. No papers are accepted late. What's today? October 13th. I'm asking you for a page due November 20th. If you don't get it done, then you don't get it. I think that's fair, right? 1 page, okay? We may never talk about this again. I'll put the information on my website, but we may never talk about this again. You know what you need to know. Keep track of it. It's your job now. It's not my job anymore, okay? I might say something on the 19th. Oh, by the way, tomorrow's the 20th and your essays are due. But I may not talk about it again up until then, okay? As they come in, I will grade them, post them. I don't return them until I'm done with all of them. But as soon as I get your paper, I will grade it and put your score in. Okay?
How many points do you need?
20. The easiest 20 points you're ever going to get in math land. Because, I mean, obviously you're writing about yourself, so content, I'm not grading on content. unless you don't write about what you're supposed to write about. Okay? Everybody clear on that?
So because we can turn it in from now to then, we could choose to put it on this quarter.
No.
next quarter.
No, it's a second quarter grade.
Okay.
It's a second quarter grade. Okay? All right, good. All right, now let's look at our quick review then. And get ready for a quiz on Thursday. Okay, list the possible rational roots. Here we go. Possible rational roots. List them. What are they for this problem? Number 1. Plus or minus 7 and 1. And then 7/3 and 1/3. That's the list. That's how you, if it says list them, that's how you list them. List the actual numbers. So plus or minus each of these options. All right, now you're going to use that idea to find the zeros of this polynomial. All right, so you know what to do, right? What do you do?
Possible rational roots and
Which
divide.
would be factors of 3, so 3 and 1 basically, plus or minus. So what do you think?
Synthetically divide.
Looks like -1 might work. Let's give -1 a shot. Yeah, there we go. So it says find the zeros. So one of my zeros is -1. What do I do now?
Factor.
So x squared minus 2x minus 3. X minus 3 plus 1. Uh-oh. Did I factor that right? So what does that mean?
You have 2 negative ones.
-1 has multiplicity 2. That's a vocabulary word from yesterday. What does that mean? That root happens twice, and then the other one is 3. Oh, great. Okay. All right, what's next? Oh, now this next one. I don't know if we have encountered a problem like this or not. Could we do that problem just like we did this one? Absolutely. This one, though, is a little bit special. If you notice, you could factor it. That problem is in what we call quadratic form. Now, I'm not telling you that you have to do the problem this way. You don't. You could do that problem just like you did this one, exactly the same way. But if you notice, it's in quadratic form. And what that means is, remember, a normal quadratic equation looks like this. What's the relationship between these two powers? That one is twice this one?
Yeah.
So whenever that happens, whenever this exponent is twice this one, and there aren't any, like there's no cubed in here and there's no plane x, it's just these 3 terms, you can go ahead and factor it like a regular quadratic if you want to. The difference is, here it says x squared equals -1 and x squared equals 4. So x would actually equal plus or minus 2 and plus or minus 5. Would you agree with that? Now, if you didn't notice that, and it's okay if you don't, I mean this sure is faster, but if you don't notice that, then what are you going to do with this problem?
Divide it
You're going to pick some
twice.
PRRs, right? And we know the ones that are going to work are 2 and -2, because we already solved it, so we know that. And you would divide them out, just like you did here. Okay, there's one more. Okay, this one doesn't have very many PRRs. Anybody see one that works? I think 2 works. Okay. So my job is to find the zeros, so one of them's 2. Everybody still with me? All right, now what? What's left? X squared plus x plus 1. And that's what makes this problem a little bit different than the one that was here before I erased it. That does not factor. So what are we going to have to do? Quadratic formula, or complete the square, but I would use the quadratic formula. Negative b plus or minus b squared minus 4 AC. Oh, not only is it not going to factor, but the roots are going to turn out to be imaginary. So -1 plus or minus I root 3. Is that right? So everybody should be able to do that. Okay. All right. 3 says write the equation of the picture. All right. Now this actually is like a homework problem. Okay. Let's start with these points right here. Those are really important points, right? What do those points tell me about my equation?
It's bounce off, so it's going to be squared.
Oh, so what's going to be squared?
The x plus 1.
X plus 1 is going to be squared, and x minus 4 is going to be squared. Now, if this weren't here, then I really wouldn't be able to do much else except know what about this coefficient. From the shape of the picture, what do I know about that coefficient? It has to be negative, because even powered functions are supposed to look like this, right? This one is upside down. So if I didn't have that point there, I would just know that that coefficient was a negative number. But now that I have an actual point there, I need to find that coefficient. Knowing that it's negative isn't enough. I have to know it's negative what? Do you remember from that homework problem? How did we figure out what that coefficient is?
I think x is 0.
This point right here has to be on this equation.
Oh, you do.
So if I put -10 in for y and 1 in for x, that equation has to be true. Would you agree with me? So what do I end up with? 1 plus 1 squared. I got -5/18. I don't know, check my arithmetic. Now, if I didn't give you this point, or if this point weren't in the problem, do you understand how you wouldn't be able to figure that number out? The only way you can figure out that number is if you know another point on the curve. If I didn't have that point in there, then all you would know is that, I don't know what that number is, but it's gotta be negative. If you are given this other point, some other point, not the zeros, but some other point, you need to find your coefficient. All right, find the maximum area of a playground. If it will be fenced on 3 sides, the 4th side is the school building, the playground is rectangular, and you have 520 meters of fencing. You've done this before. Here's the school, here's the playground, here's the fence. What's our setup? How are we gonna get this ball rolling? Dan?
For the 2 length, put x, and then put 520 minus 2x.
All right, let's stop right there. Does that make sense to everybody? I think he's right. It makes sense to me. I don't know what the dimensions are, so I'm gonna let one of them be x. I'll let the matching ones be x. And then the other one has to be 520 minus 2x, because this is 520. All added up is 520. Okay, then what, Dan?
You would find the area of those by doing length times width, so x times 520 minus 2x. And then you...
Everybody still with him? So his equation is going to be 520x minus 2x squared.
And since we're just looking for the vertex, you could just use x is negative b over 2a.
Now, how do we know we're looking for the vertex? What's the key word in the problem?
Maximum.
Maximum. So the vertex, anybody remember the formula besides Dan? Negative b over 2a, and you gotta pay attention, these equations are often out of order. So here's your b, here's your a.
So x equals 130.
About 130, you said?
We'll just plug those back into it.
So the dimensions would be 130
260.
by 260? Is that right?
Yeah.
And what does it say? Find the maximum area. So the answer would be whatever 130 times 260 is, that would be the actual answer, because it says what's the area. 130 by 260 are the dimensions. Everybody okay? All right, last one, just a little function evaluation. Okay, and our function is 9x squared, 5x 10, here we go. 9 times negative x squared squared minus 5 times negative x squared plus 10. So what do we end up with?
Give 9x to the
Would that be negative? I don't think that's negative, is it? Isn't that 9x to the 4th? You're squaring the negative. What about this one? Plus 5x squared plus 10.
It's not going to be negative 9.
Okay, why? Tell me why you think that would be negative 9.
Because it's negative in front of the a.
Okay, but we're squaring now. We're plugging in negative x squared here, and we're squaring it, so it's going to become positive, right? Let me see if there's anything any different. Find the review 2125 extra problem sheet. It's tight. Review 2125 extra problems. On the back of that is a makeup quiz. Let's look at that. Number 2, we haven't talked about that yet today. On this makeup quiz, number 2, is -3 a lower bound? How would you go about answering that question? Here's your polynomial. How would you go about answering that question? Grace?
You plug in, or don't plug in, but do like the thing with the -3,
Mm-hmm.
and then once you like solve it out, if the values are all same, then it's a lower bound.
Very good. So let's see what happens. Keep an eye on my arithmetic. Did I divide right?
So it's not.
So the answer would be no. And how would you explain that?
It's alternating.
We're not alternating here. Some of them alternate, but they're not every other one like they're supposed to. So the answer is no. -3 is not a lower bound. And how would that help you? If you were doing this problem to find the roots, and you did -3 and you got this, that would tell you -3 is not a root, right?
It's also not the least.
It's also not the least one, so you might as well go ahead and try -4 and -6 and whatever other ones are in your list. All right, is 4 an upper bound? Well, we're going to do exactly the same thing, right, for 4? Only this time, Grace, do you remember what happens this time if it's an upper bound?
Yeah, the values are getting bigger.
They all have the
Not
same
not
sign.
necessarily getting bigger, but staying all positive, yeah. Oh, whoa. I think, did I get a negative there?
Yeah.
No, I'm not even gonna finish then, because like Grace just said, they have to be all positive. So is 4 an upper bound?
Mhm.
No, because the signs aren't all positive in the quotient area down there. Right next to that's a little quick review. Let's look at that real quick. Oh, there's some stuff on here we haven't talked about in forever. Number 1, write the equation of a linear function where f of 2 is 1 and f of 3 is -2. Okay, this is section 1, the very first set of homework problems on that page. What are we doing here?
Those are just 2 coordinates.
These are just 2 ordered pairs. Very good, Dan. These are just 2 ordered pairs. And what do we mean when we say write the equation of the linear function?
Find the slope.
Yeah, write the equation of the line. So we need the slope, which I got as -3. Double check that for me. I'm still so keyed up from Math League. And
That was hard.
today was a hard one.
I didn't know.
Yeah, today was a hard one, no question about it. I know when we graded Dan's paper, we were all excited because you got 2. And up to that point, every paper we graded had been a 1 or a 0. So I think we got some higher ones later, but you may be on the leaderboard, man. All right, what do I do after I find the slope of -3?
You plug in to
So I either do y equals mx plus b or point slope with one of my points. So I'm doing point slope. So I got negative 3x plus 7. You should get the same thing if it's right, even if you do it the other way. Any question about number 1? Write the equation of the quadratic function whose vertex is negative 1, 4 and contains the point 3, 5. So in other words, quadratic function, what shape is that? That's going to be a parabola. And its vertex is at negative 1, 4, and it contains the point 3, 5. Any thoughts on that? We did these. But again, it's way back at the beginning of the chapter. Anybody remember? So we know, like if we were walking down the street and we found an equation that looked like this, what would we know about this parabola? Its vertex is at negative 1, 5.
What's that 1, 4?
So we know that our vertex is at negative 1, 4. And the only thing we don't know is that coefficient right there. But we do know that that coefficient has to make the parabola wide enough to pick up this point, right? So this is exactly like what we did a minute ago with that curve. You have the basic structure of the equation is done. You need to rig it so that it goes through that particular point. So if we put in 5 for y and 3 for x, we're going to be able to figure out what that coefficient has to be to make the parabola wide enough. So 1n equals 16. You okay with that? Does it make sense to you that that number would have come out positive?
Yep.
Because the parabola opens up. Okay, object is thrown so the height is given by this equation. You've seen that kind of equation before. This gives the height. Okay, when does it hit the ground? Okay, this equation gives the height. When does it hit the ground?
0.
Put 0 in for the height. How do you want to solve that equation? You've got some options.
Into a calculator.
Well, this is no calculator problem, so certainly you could graph it on your calculator. Can I just factor that?
Yeah.
Take out I'll just take out a negative 4t. Maybe I'll just take out a positive 4t. What would I be left with if I took out a 4t? 5 minus t. If I take out a positive 4t, I'd be left with 5 minus t. So what does that say? This one says t equals 0. And this one says t equals 5. So when is the ball on the ground?
0 and 5.
At time 0, so at the beginning, before you throw it, and then again after 5 seconds. It goes up and comes back down. I guess this means what is its highest point, and then when does it reach its highest point? Okay, now wait a minute. What shape is this equation?
Probably.
Opening
You just use the
down.
vertex.
So if I want to know about its highest point, I really just want to know its vertex maximum. So x equals,
Negative b over 2.
again, this equation's backwards. So it'd be negative b over 2a,
5 halves.
5 halves, 2.5.
Mm.
Now, I think, you guys, you could have figured that out from the first answer you got. Because you figured out that the ball was on the ground at 0 and 5, right? What do you know about parabolas? They are symmetric. So where would that highest point be? Right in between 0 and 5, right? So it all makes sense. Okay, what does this represent? That's your T. So what does this tell me? The ball is at its highest point after 5.5 seconds. What is its highest point? How would I find the actual height? What would I do? Plug in 5 halves back. This is your height equation. This gives you your height. So put in 5 halves. So 20 times 5 halves minus 4 times 5 halves squared. Okay, what is that? 50 minus 25. I double check my arithmetic, but I think its highest point is 25 feet. Okay, and then the very last one, again, this is so old stuff here, we talked about it, but this was out of section 2.2. Rate is inversely proportional to time. All right, wait a second.
So R equals G over K.
Inversely proportional is y equals k over x.
So be R equals K over
So
T.
this one would be r equals k over t. Rate is inversely proportional to time. This is your inverse variation. What's your direct variation equation? Y equals kx. Yeah. So you need to know those two formats. So here's the equation. Find k if r is 60 and t is 2. Well, that's pretty simple. It would be 120. The hard part's remembering the format. All right, got a couple things we need to look at for today. That's review. So now we've done some review, getting ready for a quiz tomorrow. Or Thursday. Quiz on Thursday. Okay, so now we need to look quickly. This test is only over 2.1 to 2.5. Did anybody have an issue with the homework problem last night? Because tonight's homework's going to be in the same section. Anybody have an issue about anything? Vincent?
I do 13.
13. That polynomial function, zeros, and multiplicities, and put those listed. So 1 and negative 2. So 1 has a multiplicity of 2, and negative 2 has a multiplicity of 3. Okay, Vincent, what does it mean when we say it has a multiplicity of 2?
It's a root twice.
It is a root twice. So in other words, you're going to have x minus 1 as a factor twice. And then you'll have x plus 2 as a factor 3 times. There's your equation. Now, I told you you didn't have to multiply that out because that's good. That would be a lot of multiplication. But here's what I kind of want you to keep in mind. Were you given any other specific information about this curve? In other words, were you given any other point on the curve? No. So this is all you can do. But if somebody had said, and it has to contain the point, 7, 13, Then you would put in your 7 and your 13 and find the actual coefficient that's on this, but they didn't give you enough information to do that, so we just stop right here.
Okay.
All right, anybody else find something in the homework last night that was perplexing? Grace?
So on number 9, I did multiply it out,
Uh-huh.
and,
I wanted you to multiply that one
okay,
up, good.
okay. Can you get ix squared, or would the squared go to the I also?
Actually, you should not have any i's left over. Did you say number 9? Did you remember that if I is a root, so is negative I?
Yeah.
Okay, so I would, when you FOIL these two factors, which would be x minus I and x plus I, you are going to lose the i's. There should not be any I in your final answer. Because when you FOIL these, you get x squared plus xi minus xi minus I squared. These are going to cancel. And what do we know about negative I squared? It's I squared is -1, so that would be x squared plus 1, that you then can go back and multiply times these guys. Okay? So the answer to your question is, it can't happen. It's not going to happen. Bailey?
Number 23.
X cubed minus x plus 3. Okay, what am I supposed to do here? Find the zeros? Basically. All right. Okay. So, you tried all your PRRs and none of them worked? Let's take a look at what happens. When you try one, because I'm just going to make a list. These are my PRRs. These are the only options I have. Right? So I'm going to just see if any of them work. No, this gives me 3. This gives me 2. No, that gives me 3 also, doesn't it? 3 gives me 27, and -3 gives me -21. Wow. What do I do? None of my PRRs work. What does that mean? They're what? No, not necessarily. They can't, first of all, they can't all be imaginary in this problem. Tell me why I'm absolutely guaranteed at least one real root.
Because if you had an I, there would have to be 4.
Exactly. Imaginaries come in pairs. Could I have 2 imaginaries in this?
No.
Yes. I can't have 3. So there is a real root out there somewhere. It just isn't rational. Remember when you do your PRRs, it's possible rational roots. The root we're looking for is irrational, which means it's something like the square root of 2. It's some non-terminating, non-repeating decimal. Here's what I'd like you to think about though. When I put in 1, I got 3. When I put in -1, I got 3. When I put in 3, I got 27. And when I put in -3, I got -21. Now, all these dots are connected. I don't know what's going on here. I have no idea. I'm just putting some squigglies. I'm making those squigglies up because I can't connect them with a straight line, so something's going on there. However, the position of this point and this point guarantee me what? These have to be connected. So what am I guaranteed? There's a root right there in between -3 and -1. Because when I put in -3, I was down here. When I put in 1, I was up here. So somewhere in between there, I cross the x-axis, and that's the point I'm looking for, okay?
Can you, for that one, if you like know, so like, you know how with every odd degree, you have a real coefficient, you have like one real number.
Yeah, well,
One real zero.
every odd degree is gonna have at least one real zero, yeah.
So could you assume that you're gonna have like 3 other complex numbers?
Well, there's only 3 altogether, so can you assume that the other 2 are imaginary? It would appear so based on what I've got here. That won't always be the case, but based on the points that I plotted, it would appear that it only crosses one time. Now, we still need to figure out where that is though, okay? So where did we narrow it down to? What did we say? It's between -1 and -3? So let's try 2. Is 2 going to work? No, it's not even a PRR. But it gives me a positive answer, okay? 2 gives me a positive answer. So when I put in 2, I get a number up here. So now what do I know? Where is it? Okay, let's open our minds here. Let's think for a second. We knew that we had to have a root between -3 and -1, right? Because when we put in -3, we got a negative number, and when we put in -1, we got a positive number. And what happens between negative and positive? You get 0, and that's what we're looking for. So then I said, all right, let's put in -2. I did not get 0, I knew I wouldn't, but I got a positive answer. So what does that tell me about the number that I am looking for? Trevor?
It's a number in between -2 and -.
It's in here somewhere, right? So maybe I would try, if I were doing this by hand, I might try -2.5. And it's either going to be positive or negative, right? And then that will narrow it down where I look further. Back in the old days, pre-calculator, that's how we had to do it. We just kept narrowing in on it. All you guys have to do is graph this and do second calc 0, and you'll find it.
If you put in -2, then you get -3 as the answer.
Oh, you get -3?
Yeah.
Oh, you do. I put it in 2. I meant -2. You're right. Okay, that changes. Well, it doesn't really change our conversation. It just says now, not there. It's here where I look, because this is where the sign change happens now. Yeah, thank you, Grace. I didn't have a negative on my A. Thank you. Good change. Yeah, I put in +2. I meant to put in -2. Thank you for pointing that out. So, Trevor, do you see now? You were exactly right based on what we had before. But now, it's actually between -1 and -2. Bailey?
So,
No. Complex roots are like 2 plus 3i. They have i's in them. Okay? A number like we're looking for is simply irrational. It's still a real number. It's still going to exist. It just doesn't terminate as a decimal. All right, you got a homework assignment. You will do it and be ready for a quiz on Thursday.